So another rational function. We're going to factor this if possible. Two things if you do not like factoring quadratics with a negative to start with. You could take that negative out by factoring out a negative. That may make things easier to factor for you if you're used to factoring with a positive a value. So I'll factor it that way first, if it can be factored. So that negative would still be out in front. It would have to be 2x and x. And in order to get 5, I would need my outside to be 2 to make 4, my inside to be 1. And they would both need to be negative so that it works out to be a negative 5x when you FOIL that out or multiply it out. So there it's factored. As far as part A, our non-permissible value, x can equal 1. Question of whether that is a whole or a vertical asymptote. Now that we've factored our original equation and it doesn't cancel out, that tells us that we have a vertical asymptote at x equals 1. Part B, to check out if there's going to be a horizontal asymptote or an oblique asymptote. Again, we're going to look at the highest power in this whole thing, and you see that it's an x squared. On the top of my function, I have 2 of them, but I have no x squareds on the bottom. Now, it's going to be tempting. Some of you are going to want to put 1x on the bottom, but you have to look for the highest power here, and the highest power is x squared, and we have none of them on the bottom. Now, this would mean I'm dividing by 0, which is not possible, which tells me I have an oblique asymptote. For oblique asymptotes, you have to go to either long division or synthetic division. You have to decide if, is this one we could use synthetic division in? Yes, because we're just dividing by x minus 1. So we'll go to our synthetic division. Negative 2, 5, negative 2. We're dividing by x minus 1, so we put a positive 1 outside. Yeah?
How do you get the 0x squared?
Because there are no x squareds in the denominator.
So then you just go to whatever the highest power on the top is.
Yeah.
0 on the bottom.
So we're going to get, I mean, as far as looking for a pattern, you're going to get an oblique asymptote whenever you have a higher degree on the top. So if you can see that and don't want to do this with the fraction, that's fine. Since there's a higher degree on the top, that is going to mean that I'm going to have an oblique asymptote. The only time that you don't get an oblique asymptote with a higher degree on the top, technically, that's over 1. That does have a higher degree on the top, but that's just a line. And you'll be able to recognize that that's just a line and it doesn't have an oblique asymptote. But when you do have a polynomial on the top and the bottom, and the higher degree is on the top, that's going to tell you have an oblique asymptote. If you look at the previous one, you had the same degree on the top and the bottom. That's going to give you your asymptote, your horizontal asymptote, whenever it's the same. But when it's higher on top, you're going to have an oblique asymptote. We're going to look at it, we're going to see one in example 4 that has asymptotes and a hole. So that's possible as well. So we'll bring down the negative 2, add them up, and from this, you don't have to worry about the remainder. The negative 2x plus 3, which is what you get when you divide it, that is going to be your oblique asymptote. Because this means negative 2x plus 3 remainder 1, and just the negative 2x plus 3 is what your oblique asymptote is going to be. Part C, X intercepts. When we look at our original equation, yes, when is the top going to equal 0? Well, we factored it. You can see that it's going to equal 0 at x equals 2 and x equals 1/2. and our y-intercepts. That's when you plug in 0 for x. Again, might be easiest to go to our original equation before it was factored. See that you're going to be left with negative 2 over negative 1. So our y-intercept is at y equals 2. We may need to add some extra points to this. We're going to see after we start graphing. Okay? Start by labeling our asymptotes. Go back up to A. We found out that there was a vertical asymptote at x equals 1. We had an oblique asymptote that its equation was negative 2x plus 3. So go to your y-intercept at 3. Slope down 2 over 1, down 2 over 1. There's our oblique asymptote. We know that our y-intercept is at 2. And we know that our x-intercepts are at 2 and 1/2. Labeling those points. Yeah, and we're going to label our oblique asymptote. So now to decide whether or not we need more points, we look at our vertical asymptote. And we only have one vertical asymptote. Do we have points already to the left of that vertical asymptote? Yes, we have 2 of them. So that means we know it's got to approach our asymptote there, and it's got to approach our asymptote there. Do we have any points to the right of our vertical asymptote? Notice I'm not saying worried about my oblique asymptote. For my domain, it's really going to be affected by that vertical asymptote. Yes, I do, right? I have the point 2, 0. So this has got to approach an asymptote and approach, that is a bad little curve there. There we go. Approach the asymptote that way as well. And we're done. There's going to be nothing in this section here and nothing in this section there. Question number 5.